Okay, guys. So it's already 2 hours. We'll wrap it up quickly. So I have my printf. I showed you. We have the PA2 and PA3 alternate functionalities, all that settings we have. Now we call this UART init function. So here you see I have not configured the GPIOs and everything. I am just configuring the UART, baud rate, stop bit, parity bit, everything, and I call the UART init function. So how can I initialize this UART without initializing the GPIOs and enabling the clock? So what it does is the UART, all the init functions, they provide us a callback function called MSP init function. So I have this block diagram with me for the HAL driver model. So this this is some of the PDF. I don't know from where I got it. I will put it on the group. This PDF tells us about different HAL and LL drivers and what the model, how we use the HAL and LL drivers. So here, if you can see that we have the main application, and in the main application, we have a handler for any peripheral. We initialize the handler parameters that I just showed you for the UART and call the init function. And it will go to the particular driver. The driver is named as STM32 for, in this case, F401RE HAL triple P.C, the driver file. The driver file executes the HAL init function and gives us a callback function. So this callback function we need to define in our application only. So this is defined in the HAL MSP.c, and this MSP.init function we need to initialize all the other hardware peripherals on which this peripheral is dependent on. So this might be dependent on RCC for using the clocks. It might be dependent on GPIO if it is using any pins. If it might be dependent on DMA if you want to transfer data with DMA. If you want interrupts, it might depend on NVIDIA services needs. So this can be done here in MSP init. So all these functions are here, placed in these header.h files. Also, if you enable any kind of interrupt, so the interrupt handlers are placed in the it.c functions, and these interrupts they call these particular functions. And after declaring the interrupt handler, the interrupt also give us a callback function. And those callback functions, what do you want if this interrupt occurs? You can mention that particular piece of code in this callbacks. These are process complete callbacks or process error callbacks. And at last, we have some deinitialization functions. So if you want to deinitialize the peripheral, it will deinitialize. And again, it will give a callback function called MSP.
Sumit, sorry to interrupt. Screen is black.
Screen is black. Okay, I will share my screen again.
Also tell the difference between HAL and LL. How is it interacting with the peripherals?
Yeah, okay. Yeah, so I'm sharing a screen again. Let me know if you are able to see.
We can see.
Yeah, so if this block diagram is clear to you. I will move ahead. So these are a bunch of, this is the flow in which we write application. Um, we call in it, we give our any services related to that peripheral. We initialize it in the MSP net functions, and we also define the callback functions for the interrupt also in the main application. Coming to your question, the difference between HAL and LL. So these are two different kind of drivers which ST provides. The HAL is a bit of an upper level. It uses handlers for each peripheral, and it gives a bit a level of abstraction for the user. But the low level, the LL drivers that the name suggests, it gives you direct register access. So for example, here in case of UART, I am creating a handler, UART handler here as a global variable, and I'm defining the parameter. Okay, the instance I want is user2. This is the baud rate I want. This is the word length, all in all, and I directly call this function. So all the register modifications, this will be taken care by the HAL UART init. But in case of LL, this is not the case. This in LL, for setting up the baud rate, you will have a different API. For setting the word length, you will have different API. For setting the stop bit, you will have different API. So it will directly access the register and change the value, whatever the parameter you give, it would directly change in the register. So it is more low level. It directly connects you to the register level access of the peripheral. So in that way, these two are different. Okay, so I have this code UART. I will debug it. First build it, then debug it. Okay, so this is the build is done. Now I want to debug it.
So what's the difference between debug and release in the STM32?
So these are two build configurations. So if you do the release one, it will directly run your software on the MCU. And in case of debug, you just get this kind of interface, and it gets stopped on the main function. So you can step over, or
So we basically are halting the processor and we are step by step executing whatever
yeah.
we want. Okay.
Yeah, you can. Otherwise, you can give a free release also from here. So in this case, I just want to give a free release. So this is hopefully transmitting our strings. So in this case, I want like you can open any serial terminal. So this is Mac. So I'm using some different way, but you can use Teraterm or Putty in order to monitor what is coming in your serial port.
We can use logic
So
analyzer as well, right, to monitor our signal, right?
yeah, you can use logic analyzer to see the bits, what bits you are getting, but to print the characters, you can use serial port terminals like
Mm-hmm.
put.
Because here we're not having any console. That's the reason we are basically using this. But we can also use this open OCD concept, right, where you can directly print it on our this screen itself, right?
Yeah, you can use semi-hosting. There is a feature from the debugger uh, in which you can use semi-hosting and you can print uh, whatever you want on the console itself uh, without using any kind of peripheral like you are.
So you have basically switched on your Bluetooth or something, or how?
Sorry.
Have you switched on your Bluetooth, or how does this thing work? How did you integrate
Uh,
this thing?
no, no, this is just a command that I'm using in order to get my serial port printed or to show you what is coming on my serial port. In Mac, in Windows, you can just use the Terra term and
Mm-hmm.
open the port. What There will be a list of ports, the COM ports that you want to use. There
Mm-hmm.
will be an ST COM port. You can just select that
Mm-hmm.
port, select the baud rate, the stop bit, everything.
Mm-hmm.
Yeah, I'm giving this command. This is the serial port number.
Mm-hmm.
It's
Mm-hmm.
a screen command. This is the baud rate I'm giving, and it will
Mm-hmm.
print whatever coming on the serial port. So here you can see it is printing the count. So we are in the while one loop and we are printing a count and the string calling from the main loop. So you can do the same with Teratum. Uh, so
Okay.
that's all from head. So if anything else, I can
What is
help
GDB
you.
server? What is this role of this ST link, and how is it connected to the inner things?
Hmm. Okay. Okay. This is a little off the topic, but in short, if I tell you, OpenOCD is a way. It uses a configuration. Okay, the OpenOCD open configuration debugger, it uses a configuration that ST provides for each board. I will show you in properties. Not in properties. It will be in debug configuration. So we are here, debugger. Mm, This is taken care by the cube ID in its oh, internals. I'm not seeing it in here in the Mac, but I generally work on Windows for my office work. So there I can
So
see
here, see, there's
how
this debug probe,
else.
right?
Mm-hmm.
And this can select options, right? Can you just click on it once?
Debug Pro. Yeah,
Yeah. So there are
you
three
can
options,
use
right? ST-Link, OCD, GDB server. Right now we are working on GDB server, right?
heat.
Not Open OCD. So we need to
Yeah,
enable
here.
only this option, right? Open OCD thing.
Yeah, you can use if you have different probe, for example, a Sega JL link, then you can use this one. Otherwise, you can use with ST link, you can use directly the GDB server or OpenOCD. Um, these I don't know. Don't have the much understanding of it, but OpenOCD, it uses a configuration file. You can use this is the script file uart_printf.cfg. Um,
It's totally black again.
I will close it.
Now we can see one screen of UART printf. Yeah.
Okay. you can see.
Yeah.
Yeah, so it uses a configuration file in order to know which kind
We
of
cannot
board we
see the
have,
screen. Yeah, now we can see. Yeah, please continue, Sumit.
which kind of board we have, what Cortex chip we are using, M4, or everything about the related to the MCU chip and the board. We have it in the configuration file. And the OpenOCD server, what it does is it opens one more server on one of the port of our PC, and the ST-Link, it works as a client, and it communicates with that GDB server in order to uh, gives any command to our MCU. I don't know if that makes sense. ST-Link, if you can say that it is an interface to look into each and every register of your MCU. So if you have all the peripheral registers, you have the core registers. So they will be located at some specific address. You can directly access those registers, you can modify them, you can read them, and you can reset your peripheral MCU. Like basically the whole, you can control it. You can see what is running on your chip. You can halt the MCU, everything that you want to control, because we don't have anything but the debugger in order to control our MCU other than our code. So either you can use your code to control the MCU, or you can use a debugger in order to stop, in order to execute step by step. So all these functionalities, if you want to use a debugger, and the uh, debugger, it creates some signals, some electrical signals that are required for the MCU in order to, for example, halt. The uh, we cannot directly create those signals from our PC. So these are, for example, if you are using the JTAG interface, so JTAG will require some kind of electrical signals in order to operate some protocol. We from our PC we cannot create those electrical signals, so we need some intermediary chip uh, in order to create those signals for us, and that is the ST-Link. If that
Okay, so
makes sense.
JTAG is just like ST-Link only, right? It's just that different protocol name it is we are giving it, right?
JTAG is a protocol, and ST-Link is a debug probe. ST-Link is a chip, you can say, which from which you can use the either the JTAG protocol or the SWD protocol, serial wire debugger. Also, you can use. These are different kind of protocols you can use to debug your processor. You can use either SWD or JTAG. Uh, ST-Link you can see, if you have a nucleo. I have a nucleo board. Uh, uh, from where you are connecting the board, it will have a small chip. So that is and it is also breakable. You have lines on it, so you can break the ST-Link away from the board. So these are two different entities. ST-Link is just another board. We also provide another ST-Link V3s that are small, this size boxes, which you can connect to your PC, and then those you can connect
Mm-hmm.
any board through a JTAG interface or SWD interface, and
Mm-hmm.
just deep microcontrollers.
Okay, so you mean the white color thing about that we get from ST, that is what
Hmm.
you're trying to like, we can basically connect a different board to say any ST board and any microcontroller board we want to connect. We can use this thing interface and connect
Hmm.
different board and try and communicate also,
Yes,
right?
you can use. Yes, you can use the same ST-Link. Not like you have to I don't know how to use that is already present in the board, but there will be a separate ST-Link boxes that are shipped that are sold by ST, and you can use those boxes to debug different microcontrollers. Same thing. You have J-Link. J-Link also is a debug probe. You can use it to debug different microcontrollers.
There's this jumper thing which is there over here. We can see over here. Like, wait a second. Yeah, there's this jumper thing over here where if we remove it, ST-Link
Hmm.
discovery, and also there is this
Hmm.
thing written here SWD, which is your CN2 connector. So here we can basically connect, right?
Yeah, maybe you can connect. We need to see the schematic of this board in
Yeah,
order to
we
yeah,
need to see
connect.
the schematic.
Yeah, cool. Did you get the block diagram?
I need to again basically say I did not see, but maybe in the next session at the start I can maybe take up.
Yeah, sure. Yeah, it's already 2 hour and 15 minutes into the session, so let's not make it too long.
Let me see if we have anything in the chat. Nothing we are having. No questions by Naveen. Srinivasan, any question? Okay, I guess we do not have any questions for now. Okay, then thank you so much for taking up the session. We actually enjoyed the session a lot. Got to learn intensities of like how the things happen back end. Thank you for telling us the behind the scenes thing. Uh, okay, I'll come to the point where we need to have different components with us. Till now, we do not need any components. I'll let you know if any components are required. Okay. Okay, then let's wrap up the meeting.